All right, let's get started. So hello, everybody. I am Diego Medrano, a community support engineer. Welcome to Tableau's Think Data Thursday, making Tableau 10.2 work for you with Bora, Beran, and Kent Marten. We also have on our panelist list, we have Lenny Redinger and Patrick Vanderheide from our community team. And if you've been in the forums, then you likely know those names and you've seen us around. So before we get started, we're just going to go over a couple things just to make sure that everybody is prepared to participate. So there should be a chat box and a Q&A box. Anybody is welcome to ask any questions. If you know the answer, please feel free to chime in. Otherwise, we're kind of going to use our discretion on answering those questions. So if you want to clarification on something, I can go ahead and let the presenters know, but otherwise we're likely going to wait towards the end for our Q&A session to actually answer most of those questions if there's anything left over. Keep in mind that everyone can see the questions that you ask. By default should be set to all participants. So if you ask something, anybody can jump in. Currently everybody is set to the mute position. Let me know if you have a question that you'd like to ask out loud, but otherwise sticking to our chat should be just fine. So without further ado, we're going to go ahead and I'll welcome our presenters. So first up, we have Bora Beran, who is one of our product managers at Tableau. And he is from the team that brought you the level of detail expressions, LOD, which we all love, clustering, type-in pills, regular expressions, R and Python integration, box plots, stored procedures, split, pivot, and many other features. So a lot of really great stuff has come from his team. Prior to joining Tableau, Bora worked at Microsoft Research, SQL Server, and Windows HPC Server on tools and infrastructure for large-scale computational models, simulations, data mining, visualization, and knowledge representation. He holds a PhD from Drexel University and is a reviewer for several scholarly journals in the area of technical computing. He enjoys blogging about new Tableau features and interesting advanced use cases for Tableau. Bora has been a huge help in our forums for anybody who has been in there regularly, and so we're lucky to have him. We're really excited to have him today on this Think Data Thursday. And then we also have Kent Marten, who is a product manager as well, and I've been seeing his name pop up way more in the forums lately as well, and so he's been contributing some great knowledge to our forums. Kent's a product manager for maps at Tableau, including all things spatial. Kent has worked on mapping software for the last 12 years, and he's confident the next few years are going to be the most exciting. You will find Kent actively engaged on the forums and on Twitter at DataKmart. Feel free to reach out anytime if you have a question, comment, or want to share some feedback about mapping in Tableau. And as I said before, he's been really great. I know that he's always really willing to engage with users on how they're using the product and answer questions. So I know that if you have questions, you really should reach out. So I believe, Kent, you were going to kick things off.
Yeah, thanks, Diego.
Yeah, thank you.
Oh, go ahead. So should I just get going?
Yeah, go for it.
Great. Thank you, everyone, for joining Think Data Thursday. This is my first Think Data Thursday. I'm very excited about it. I have a few goals to cover in my section. Hopefully, I'll take about 20 minutes. Leave lots of time for Bora. But I'm hoping to show you some ways to work with spatial data in Tableau 10.2. I don't know if all of you have had a chance to play with it yet, but it's pretty awesome. I'm going to cover a few well-known use cases. One of the things I'm also going to talk about is where do you actually get spatial data from? I know a lot of people are beginners and new to spatial data. I've even seen with the IronViz entries, a lot of our ZenMaster and really well-known visors out there have sort of had some questions about where do I get started? Where do I get this? I'm new to working with spatial data, so I'm going to cover some of that. And hopefully, just hopefully, you might actually learn something, just a little tidbit to make you more productive with 10.2. So I'll jump right in and make sure that I share my screen. Yes, I would like to share my screen. All right, so hopefully you can see that I'm looking at Data.gov. So
Yep, looks good.
if you're in the United States, this is a great place to go looking for spatial data. And I'm going to go through this kind of quickly, but if you're looking for data out there, you're probably not going to type what I'm about to type. I'm going to type a file format, shape files. But you might actually type something you're looking for, like an urban district, an urban area or something like that, or a school district. But I'm going to type shape files and just see what comes back. And the point I'm trying to make here is that when I get 7,700 results, there's a lot of spatial data out there. And you can see, even from data.gov, they have a really good portal for working with even municipal data sets from all over the country, not just federal data sets or anything like that. So it's a great resource if you're looking in the United States. I'll bounce around a little bit. What if we do the same test in Australia? So data.gov.au in Australia, 1,200 shapefiles. And again, look at the formats. They're not all shapefiles, right? They have GeoJSON, KML, WMS servers available. So lots of spatial data and content for people to work with. Now, if you're not looking for a national data set from the US or Australia, this is a great place to go looking for, especially if you don't know where to look for data in, say, Africa or some of the areas of the world where there's just not a lot of data available, or it's been centralized in a few of these places. The Humanitarian Data Exchange is a great place to go looking for data. And again, I run my shapefile test. Last night there were 860 files. This morning there's 863, so even more contributions. So those are some great places to get started looking for data. And again, if you have questions and you're looking for something specific, you can always reach out on the forums, and I'm sure the community, myself, lots of people can help out. So for this demonstration, I actually want to start kind of from scratch. What if I've just kind of learned, okay, I can work with spatial data in Tableau. I've asked for lots of data sets to be built into Tableau in the past, but now the spatial file connector is available. What can I do with it? Well, from the Census Bureau, I'm going to highlight a number of data sets that are available. It's a really, really useful site, and the Census Bureau doesn't just produce census tracts and that's it, right? If you go in here and look at the list, you can find county subdivisions, microdata areas, state legislative districts, many other areas or geographies that people have asked for to use in Tableau before, and that people have had to work around and build custom polygons to use. Well, you don't have to do that anymore. So in this case, I'm going to say census tracts, and I'm going to pick a state. I'm going to pick Florida in this case. I can just go in here and download this. I'm not going to run this download. I've already downloaded the data to use in Tableau. So why don't I go ahead and I'll jump to Tableau. So how do I connect to spatial data? Well, it's just another option here in the connection menu. I can choose spatial file. I'm going to jump to the data that I've previously downloaded for Florida. Here are those census tracts, and here's my shapefile. Now, a word to the wise, a shapefile isn't just a singular file. It is a collection of files that all work together in concert, and you need them to all be in the same file with the same naming convention. In this case, I have the shapefile. This is the thing that actually has the spatial data. I have this SHX file, an index to the DBF file, the table, the attribute information. And although those are the only 3 required files, I would 100% of the time recommend you have the PRJ file, the spatial reference information. Without it, we have to make some assumptions and we could be wrong. So I'm going to go ahead and open up this file. Hang on one second. I'm just going to draw some attention to the other available formats. So like when I was looking at the Australia data portal and all of the spatial file formats that were available there, well, you can see we connect to the most common formats now with the spatial file connector. So KML files, Esri shape files, map info formats, tables, and MIDMIF files, and GeoJSON files as well. So I'm going to go ahead and open up my census tracts for the whole state of Florida. And here I have, I have this video screen here I need to minimize. Okay. So here I'm looking at the attribute information that came along with the shapefile, right? So it's not just the shapes. These files can include lots of different attributes depending on how they were processed and created. The special file or the special field in the shapefile, the new one in 10.2 is this geometry column. So the geometry column actually includes that spatial data, 1 row per shape. So again, in the old days where you may have pre-processed some data to create a point-ordered table to build a custom polygon, you no longer have to do that when working with these common geographies. And the value in the table is just showing the geometry primitive. So it's just an alias. It says polygon, but of course the shape and spatial information is included in this field. The other thing I want to point out when working with census data is you'll often use this GeoID. This is the unique identifier, and it will come into play a little bit later when we do some more work with this data set. So what do? Geometry is a measure in Tableau. So let me just double click it. So here we are looking at 4,500 census tracts. I will say it rendered very quickly. This is a fairly detailed data set. That looks good. But when I hover over the data, it is a single mark. It's not 4,500 individual marks. Why that is? Well, in Tableau with measures, we have a default aggregation. And in this case, there's only one aggregation available for geometries, and that is collect. It's kind of like a union. It's unioning all these shapes together and making one mark. And you have to disaggregate those things by choosing a level of detail. So usually you'll choose this unique identifier in your data set, the thing that you know. But you could also go to the analysis menu and say turn off aggregate measures, and you get all these individual shapes, and you can see the interactivity. I'm just going to turn that back on, go ahead and add my level of detail. So great, I've got these shapes working for me. And I can look at some of the attributes in here, and I know that some of these values, the other measures I should say, A land and A water, this means area of land or area of water within the census tract. So if I go pick area of land and drop that onto color, well, obviously the biggest census tracts get the darker colors. But that's not the most interesting case here to work with this data. Most people, when working with census data, or I shouldn't say most people, but I know it's a very common case where people want to work with demographic data or socioeconomic data to help drive a business decision or figure out how to better serve the community, right? So I want to do that. I want some demographic data. Where do I go to do this and bring it all together in Tableau? Well, I'm going to jump back to my browser and go to the American Fact Finder, also a part of the United States Census. So in this case, this is going to allow me to drill down and find a table that I'm looking for, something that I'm interested in. But I'm first going to add my geographic filter. So I'm going to pick census tracts, the state of Florida. And then I could choose a specific county if I was looking at, say, just Miami-Dade County or something like that. But I'm going to choose all census tracts within Florida and add this as my spatial filter. And then I'll close this box. And then I can just type in a keyword. So maybe I'm going to look for poverty, because maybe I want to figure out where people are in need and build some programs that can help serve those people. So I could just check this box and say download. You'll get a little trigger that says, hey, we're going to zip up this data. It might take a couple minutes. So I've already downloaded that. I'm going to jump back to Tableau here and my data source and use a cross data source join to bring these data sets together. So I'm going to add this text file, again, from my Florida data set. And I know it's here, American Community Survey 2015. Yep, that's the right file. And open that up. Now to create the join between these data sets, I'm going to use the GeoID field. And you're going to see within that table, there's a ton of information, right? The census really is an amazing source of information, and it's all publicly available. I'm going to use the GeoID2 field and switch that to string. We need matching types for the join to basically execute and work. So that loads. Another thing I want to highlight with this data set, there's this GeoDisplay label field. When it comes up, I'm going to actually split this field because I know it includes actually some county information. And I'm going to use that county name as maybe some geographic context to filter my view of looking at census tracts. So I can just go in here and split. So we'll let that finish. Yep, and I'll jump back to my viz. So we're almost there, right? We had the census tracts in the state already showing area of land within the census tracts. What I'm going to do now is actually add one of these variables that looks at poverty, because maybe I want to make a decision about a program to help people in the region. So let me just get one of these population estimate ones. Oops. I'll take this. I can just drag it over the pill and replace it. And here I'm now looking at basically people below the poverty level between the ages of 18 and 64 in the state of Florida by census tract. And we did this all in a matter of a few minutes while I used the census and downloaded this data. So that's awesome. So what if, again, in many cases, I'll say we don't often look at the entire state or the entire country of census tracts, right? What might you do? Well, I'm going to take that field that I split out. I'm just going to show a filter. Make this a single value list. And I'll have to unpin my map. And I could start to move county by county. So again, this data set included this county information. I can leverage that. And now I can just start to move through. And if I wanted to go look at some of the more popular places, like go look at Miami-Dade and see where there are areas here in the south and in some of the northern little spots where there's lots of people who need some help. Palm Beach. So again, here's an example of integrating some data sets easily, working with these custom geographies. I think you can see the performance is really good. So yeah, that's a great example of working with census data. Now, I'm going to jump to another example of working with more than one spatial data set. So here I'm going to just bring it up, and we're kind of starting at the finish line this time. So I'm not building up this viz from scratch. I'm showing you the finished product. And here we're looking at housing and property values in the market and transactions within the market in the City of London. So what's interesting about this viz? Well, it has this parameter where I can go in here and I can basically choose the level of detail that I want to work with. Now, none of these geographies are built into Tableau. If you know anything about UK postal codes or the geographic data that we support in Tableau, we support the postal code district, which is basically the first 3 or 4 characters of the UK postal code. But the UK postal codes are extensive. I mean, there's over 1 million full postal codes in the UK. But I digress. So here I can look at census areas, these council commission areas, or I could look at the sector level for postal codes, again, a very detailed data set, or even the full postal code data set if you possess this data, right? Now this is a very detailed data set for the City of London. And at this scale, you really can't see much. So I'm going to go ahead and zoom in on a little region. Now, did everyone see that for a second? I just want to call out this one little tidbit. When I zoomed in there, the shapes looked kind of jagged, right? Well, the thing that we're doing, and let me unpin this again and I'll just do it one more time, is we're actually dynamically simplifying the data set to ensure that you have really good performance and that the visualization loads as quickly as possible. Now, this data set is so detailed it's not really useful at this scale to see some of the specific postal code values, right? But what we do at this point is we basically only draw things that you can actually see. And as you zoom in, well, you see some of those artifacts, but then we dynamically re-render those things. And now we see like the full flushed out postal code shape. So in this case, when working with housing market data and full postal codes, you can see the level of detail, but it makes sense to be able to zoom in and you can start to do some exploration of why these homes on these streets are so much more valuable, or the transactions on average were more valuable than homes just a few blocks away. And you can start to dig in if you knew the market, you knew the area. So how did we get this viz to work with all these levels of geography? Let me jump back to the sheet here, and I'll highlight a few things. So the first is, so here's my parameter list, right? Obviously, I'm talking about parameters. If you don't know what a parameter is, in this case, I basically wanted a list of names, like the actual geography type, and I created a parameter to do that. So if I go in here and edit, Again, strings, so just a list of names. I set a current value, provided these lists. So now that I have these values in a list, cancel that. Well, where do they come into play, right? Well, there's a couple of calculated fields that basically work off of the value that's chosen from the parameter. So you can see here on the marks card, I have chosen detail for label, chosen detail for level of detail, and then the geometry, which uses collect, is the chosen boundary. So let's look at that chosen boundary field. And the logic makes sense, right? So when someone uses the parameter, right, to choose map detail, and say they choose full postcode, when full postcode, use the full postcode boundaries geometry, which is this field right here, right? And then I can go look at the detail up here, and you would expect the exact same logic, and it's there. So when someone chooses full postal code, use this postal code field up here. So we basically used calculated fields along with the parameter to look at and work with multiple spatial data sets. So again, working back from that, this is what the data source actually looks like. I actually have a number of union CSV tables, which include all the housing transaction data. I have two shapefiles, these two red data sets. And then I have a transactions areas CSV file, which is linked to both the union table and a number of other geographic data sets. And the thing I want to highlight here is that I'm working with shapefiles here in red, a mid-MIF table, a GeoJSON file, and then, of course, for the government districts, I have a map info table. So you can work with and mash up all these spatial data sets and leverage them in a really interesting viz that allows you to explore different levels of geography. So that is I think that's a pretty cool example right there. Now, the next thing I want to cover is, well, now that we've done that, let me make sure that I'm not running way beyond time. Just a couple more minutes and I'll hand off to Bora, but I want to cover a few things. The first is some of the limits, right? So we showed working with polygons. I want to highlight that you can work with points and polygons, but if you have a spatial file like a map info table or KML file that includes multiple geometry types, we don't support rendering those mixed types yet. So that's something that we're looking into. The other very common geometry type, and you'll find this common with data sets that belong to a grid. So if you have a cycling network or bike paths, if you have a railroad network or street network or fiber and cable networks, all those types of data are stored as lines, usually, linear geometries. So we don't support that in this version, in the 10.2 version. But I'll tell you a quick workaround. If you want to get your hands dirty a little bit, you can use QGIS or another type of mapping application if you have it available to you, and basically buffer the lines to create a polygon. And you, of course, can bring that into Tableau. With respect to lines, it is one of the most important things we're working on, and we're going to deliver it later this year at some point. So don't worry, lines are coming. The other limit I want to call out too when working with KML is that we don't support directly reading KMZ files. So if you find a KMZ somewhere online, well, you can actually just unzip it, and there'll be a KML file inside. If the KML has layers of data inside of it, well, we don't support that. You're going to have to do a little bit of pre-processing there to pull out the specific layer you want to work with within that KML. So those are some of the limits right now, but know that we're actively listening to customer feedback on these things, and we're going to keep improving the support for spatial data. The last thing I want to call out here is the improvements and enhancement within the SDK. So the spatial file connector allows you to work with spatial data in these common file formats. That's great. But we also built into Tableau support for the spatial type, this underlying new field type, right? Well, we expose that through the SDK. So if you work with or want to start doing some of your own development and build something custom, one thing you can do with this Tableau 10.2 SDK is when you're creating a table, you can actually create spatial columns. Now with the spatial column, you can pass in a well-known text and create a spatial column inside of a TDE. So what does this mean? This means that you could fairly easily create a utility that reads data from your Postgres database and creates an extract, and you can bring that into Tableau. So this isn't, the spatial file connector, although it's connecting to spatial files, that Tableau supports the spatial type now, means that you can work with these common file formats, or you can do a little bit of your own work here to build a connector to your spatial database and bring data out of that. So with that, I don't know if there are any questions that we want to take on right now, Diego, or maybe I should just hand over to Bora to make sure that he has enough time for his section.
Yeah, let's go ahead and hand off. There's a couple out there. Very quick one. Will we have the workbook that you just worked on? Would you be able to post that on the forum page after the presentation?
Yeah, no problem. I can post the Florida one. Yeah, that's not a problem. I can't post the other one though.
Oh, okay.
The UK one had some proprietary data in it, which I'm not allowed to share. I'm sorry.
No worries. That was really awesome. Bora, whenever you're ready, you can go ahead and take over presenting rights. But thanks a lot, Kent. That was great.
Yeah, no problem. Unmute yourself, Bora.
Let me see if I can do that for him.
Okay.
There we go.
Sorry about that.
No worries.
Well, good morning, everyone. My name is Bora, in case you missed the intro and you were late. I'm the product manager for advanced analytics at Tableau. Now I'll give you a quick demonstration of Python integration. So before we get into demos, I would just like to do a quick preface. Well, as you know, in 8.1, we added our integration. And this is by no means counter to our commitment to enabling easy-to-use advanced analytics in Tableau, which some might have thought at the point, and now we're investing in more by adding Python support. But in that period, we also added things like forecasting and clustering, and we intend to add even more. So you can think of this Python and R integration similar to custom SQL. I'm sure a lot of you wrote custom SQL to do unions, for example, in the past, but we added them as a point-click operation recently. So while we add the flexibility by giving Python and R integration so you can access all these statistics and machine learning libraries out there, we also are committed to investing more in advanced analytics and make it easy for our customers to use. So in addition to flexibility, maybe to some it's more importantly, we want to allow customers to take advantage of their existing data science assets. And when I think of assets, I'm using it in the most generic sense. It could be existing code they have written in R, Python, or other languages. It could be existing knowledge, considering a lot of data scientists these days use things like R and Python, and SAS and SPSS are losing a lot of market share. It is safe to assume people will want this kind of functionality if they have a data science team, so they can share their findings with their audience more broadly. And we'll talk about some of the scenarios. But without further ado, I'll jump into my first example, and we'll explain more as I go along. So for my first example, I wanted to pick a real data set. This is from Seattle 911 police calls, incident response data for the past 6 years. We have an original data set. We have a point for each criminal activity that happened in the Seattle area. And I'll show you a pointer to the a hosted version of this on Tableau server. That's public facing. So you can take a look at it. If you plan on visiting Seattle at some point, you can look at spots that you should be avoiding. Okay, so let's go through this dashboard really quickly. I'll go full screen, and I'll go through a bunch of options and explain, and then we'll look at the code. So in this case, I have a filter. I can swap between different criminal activity types, and what we're seeing here is a criminal hotspot. Out of many thousand points, we're finding points where there's a lot of dense, high number of activity nearby. Burglaries, narcotics, liquor violations, and parking violations. And you can see there are some interesting hotspots. I'm told that these are the places where there's some fancy restaurants with a little parking around, so people will go get a ticket and enjoy a meal. And you can see the peak happening on Sunday brunch time. And what I did here is I actually parameterized this, because you may have, let's say, a police officer, and they may have different criteria for what qualifies as a hotspot. They may think, well, there has to be at least this many, let's reduce this, at least one incident per quarter. Now I relax the filter, I get more hits. I can say, well, they have to be at least within 200 feet of each other. Now that's another relaxation, which in this case didn't make much difference, but if I keep relaxing it, you see there's more points. Because in the city, I may have a city block of different size. In the rural areas, I may want to use a different proximity setting. Under the covers, we're running Python code to answer the question. But you can imagine, as the end user, you don't have to know anything about Python or R or whatever language running under the covers. It is just a Tableau dashboard you're interacting with, and it helps you answer your questions. And in this case, you can imagine a data scientist building this for their consumer. It could be the police officer or a renter looking for an apartment in the Seattle area. And there are just using it, interacting with it, asking what-if questions using Tableau's interface. So let's take a look at the code and what it looks like. In this case, everything is in this map code. So here is our calculated fields. And you could see this is a calculation that contains plenty of Python code. It uses NumPy, it uses scikit-learn, which is a very popular machine learning library in Python, and it passes our latitude, longitude, and distance between incidents and incident count as inputs to the model. It's using this algorithm called dbScan, which is really good for these kind of mapping applications. It's good for clustering when your data has noise. It can handle arbitrary shaped clusters. And then it's looking at the results. This is actually a clustering algorithm that returns cluster number or outliers. It looks at clumps of data. We filter out outliers and just return the clumps. So this is a script calculation. If you are not familiar with how we integrate it with R, if you go and type script in function help, you will see there are plenty of options here. And you can see Boolean, integer, real, string. These indicate the types your script is returning. Tableau has no idea what the script does. It is expecting an array back. It's to the point you have to tell what kind of data that array will contain. Is it a real? Is it a string? So based on your data type, you need to use the correct function. And if you're familiar with how we handled raw SQL has actually, and this is Excel, that's why we don't have raw SQL options, but raw SQL had a very similar concept. You actually have to provide the data type. And you're probably thinking, well, these look like parameters. Why are these not parameters? They're not purple. They're actually, they involve some conversions. Let's take a look at the distance between incidents. In this case, we're essentially doing a unit conversion. That's why they appear as calculated fields. Okay, so let's talk about how this works. So in this case, we're using Excel as our data source, but you could be using many different kinds of data sources. Since R calculations and Python calculations are local calculations, it's independent of the data source you're connected to. It could be a relational, it could be a cube, it could be a web data connector, it could be anything. It could be involving a cross data source join. Tableau does all the pre-processing of the data, all the joins, unions, and then passes the data to R. And this works on Tableau desktop and server. Tableau reads into Tableau product from the data source, and then data is inside the sheet, and that's what's being passed to R or Python for processing. If visualization is an aggregate visualization, we will pass the aggregated data. If you uncheck the aggregate measures option, then we will pass disaggregate data. So whatever you see in the viz, those marks, the values for those marks, that's what we're passing to Python. And notice how I call this external services. I'll also show you the UI entry point to configure them. We're trying to make it as generic as possible, and we'll keep adding more language support. So now it's called external services that covers RServe and TabPy. that are the components that we use to connect, to talk to Python in R, and there will be more of them. So we send the script that you just saw along with the data, and we get some results data back and display it in Tableau. Currently, we only allow you to return one column as a result. In this case, if you go back to my Seattle 911 example, what you'll see is we return a column that we're using on the color shelf and the filter shelf. Let me actually remove what's on the filter shelf so you can see the actual data under the covers. So this is the actual criminal activity. So it's not a very peaceful place in Seattle. I'm sure it's better than a lot of places, but there's a lot going on. We just hide the outliers and that they're not clumps of criminal activity. Okay. So let's look at another example, and then we'll get to how you get TapI, how you set it up on the server, etc. In the first example, we looked at a case where we had a lot of embedded Python code inside Tableau. But there are cases where you may not want to do this. And there are many reasons for this. For example, some models are not unsupervised models. You don't want to refit the model every time your data changes. You want to train the model over a large data set. Then you want to pass parameters to it and do the operation of so-called scoring as your new data comes in. For example, you can train your model based on historical churn rates, and as new customers interact with your system, you can try to classify whether they're likely to churn. So you're applying it to a brand new data set. And some of these model training steps could be time consuming. So you want to do ahead of time outside Tableau, put the model somewhere and just use it for scoring. And another advantage of this is the logic stays outside Tableau. Because of this, if you wanted to update the model, you don't have to find all the Tableau workbooks leveraging the same Python code. You can just update. You may want to update it at a centralized location. So let's look at an example. In this case, we have a model that's trained based on historical cancer data, based on Wisconsin breast cancer data set. And we have information about different kinds of tumors and how certain measurement results came out to be. And we have a supervised model that will try to predict if the tumor is malignant or benign based on the inputs. So I can type in values. I can say 4, it's still malignant. If I make this a 2, and make this an, well, let's keep changing the values, see if we'll have the benign one. Okay, now the diagnosis has changed. And you can imagine this kind of an application of, it could help a doctor with aid in the decision based on historical data, or you could be just curious putting your numbers in. And as you can see here, I was going after a different look. This is not meant to look like a dashboard. I wanted it to look more like an application, because the way I see it is, given the power you're getting from Python, you're actually building vertical specific applications in Tableau. Tableau happens to serve as an easy way of building UI, an interactive interface to a mathematical model underneath. So let's look at how this works. And here's our calculated field. It's very simple. So if you look at this, what you will notice is my script is much more different from what I showed you last time. I don't have any actual code that does any processing. All it does is it says return TapI query diagnostics demo. And it is trying to query some endpoint called diagnostics demo by passing all these parameters, the numbers I typed in. And here in this case, we have 9 parameters, and you could see arg1 through 9, and these values are passed to fill in those placeholders essentially. So how is this possible? What is diagnostics demo, and where is it defined? So let's jump into an example of how a data scientist would go through this process really quickly. So I'll go to my browser window, and we'll come to this as well when we talk about server. Here is the process I went through. This is our data set, breast cancer, and this is a Jupyter workbook. You may be familiar with it. There's actually a recent Mark Cuban tweet about how the new NBA uses data mining, and he actually had a screenshot of a Jupyter workbook like this one. So it is very popular in the data science community. So what I did was I loaded the data set. This is what it looks like. I did some pre-processing, some recoding of the values to zeros and ones, etc. And then I went through the process of fitting many different models. Since Python has a lot of machine learning models, I have a wide variety of tools at my disposal. I use this method called k-fold cross-validation, which allows you to work around some of the overfitting issues by slicing your data into multiple pieces and training on different pieces and evaluating on the others. And then I went through multiple models and look at the quality using different metrics like accuracy, precision, etc., or area under the curve. So I started with a support vector machine, ran 3 iterations. This does a grid search, essentially trying to find optimal parameters for the model fit, and I output them. I got 97% accuracy. Then I did logistic regression at 91% accuracy. Then I did a naive Bayes, 98% accuracy. Then I did a gradient boosting classifier, which is an ensemble model that is a tree model but consists of many smaller trees, and it penalizes at every step for things that it got wrong. So it's a pretty strong estimator, and this data set isn't that hard to actually classify correctly, so it actually gives me 100% accuracy rate. At this point, I feel like I found a good model. I can use this in production. So Tableau Python server, the TabPy we've been talking about, comes actually in 2 parts. It has a server component and has a client component. A client is a Python library. You can just do an import. Once you do it, you create a connection. This is where my Python server lives on my local host. And after I create a connection, I need to convert this into a function and publish there so I can reuse. Here's, you can see I'm calling a predict function on the gradient boosting classifier I created here. And this is defined outside the function, right? I didn't put all the logic here. It's all done before. There's just an object that's there that I'm using to create a classification. Then I will say I want to deploy this function called suggest diagnosis, call it diagnostics demo, and give it a name so I can reuse it in the future. And what Tableau will do is it is smart enough to say, oh, there's this model, it's defined outside Tableau. I'll go find automatically all of its dependencies and package them up into what Python calls a pickle file and publish it on the server. What this allows you to do is if you have a model like a fraud detection model, as you know, fraudulent people change tactics all the time. You don't get the, South African prince emails anymore, and they have new tactics. So your models also need to evolve with what you're trying to predict, since the data itself changes. And instead of looking for pieces of code in Tableau workbooks, what you can say is, I published my model, I'll just go overwrite it with a new version of it that works better with my new data, and all of the workbooks using that for prediction will have the latest and greatest version. So what I'll do is, essentially, I'll go and see after I publish what these models look like. You can actually go to our catalog and find out, there are functions here. This is called diagnostics demo. This is version 1. We actually do versioning for you. We'll increment 2, 3 as you go. If you publish more, I also add another example function here that does addition of 2 columns that you can see here. This is how I'm able to just call it as a web service endpoint from Tableau without having to worry about embedding any code. And you can imagine how powerful this is for data scientists productionalizing their work so people can use it in different contexts. So I'm about to run out of time, so I'll try to wrap really quickly. So how do we get to this point of publishing using these models? First of all, how do you get TabPy? You can install TabPy from our GitHub page. It's under Tableau's GitHub, and there are some setup scripts depending on your operating system, and it will install Anaconda. If you don't have it, create a Python environment, install TabPy, and get a bunch of machine learning libraries by default, so you don't have to worry about it. Or you could say, well, I don't want to install Anaconda. I'm proficient in Python. I have my own environments, or I don't even want to create an environment. Then you can just type in your command line pip install TabPy server. We'll pull from PyPy repository in the cloud and install on your machine automatically. But again, that means we're not going to install Anaconda, etc. So some machine learning libraries that we install by default won't be there. You have to manually install. And since we are just passing some Python code to a Python server, you can install anything you want on that TabPy server. If you want TensorFlow, just go ahead and install it. Tableau will be able to run those codes. Any Python function that you can run inside Python, you can run through Tableau on TabPy server. And how did I connect to this? Let me go here, help, settings and performance, manage external services. You can see it's running on localhost at 9004, and this is how you configure it. It's just like configuring our server. Now keep this UI in mind. It has server and port. If you want to do this on server, you do exactly the same thing, but using tabadmin. You can say tabadmin sets, the host name, you put the server here, the port name here, and then you have to stop and configure and start the server around this process. And now your Tableau server will know where to run Python code. And this includes to any workbook that you published from desktop will be using that Python server. Also, any new workbook you create on the server in web authoring, if you type in a script function, it'll be using that Python server. So currently, we only allow one setting per server. So if you want to have Python and R, you have to choose your poison. And we're trying to relax that. So in the future, we want to be able to support multiple configurations per site. So we want to even go beyond server and give more flexibility. Currently, we don't provide password support. That's why it's not mentioned here. R does support it, but Python currently doesn't. And this is not supported on Tableau Public or Tableau Online yet. Again, that's something we would like to, especially the online part, we would like to address sooner than later. So now I want to leave some room for Q&A. Well, thanks for your time. I'm happy to take questions.
That was great. Thanks a lot, Bora. So let's see. We have one raised hand. So let me go and see if I can. I think I have to promote them to panelists. All right, Howard, you should now be a panelist if you want to go ahead and unmute yourself and ask your question. Assuming Howard is there. Might not have a microphone. Well, if you have a question, Howard, you can also go ahead and ask it in the chat. We had another question, I believe, from Annabelle. Said, innocent question, would you be able to build these workbooks without using Python? Is it just faster to use Python?
So the examples I used, you cannot build them without Python inside Tableau because in the first one I used this algorithm called dbscan, which we don't offer inside Tableau. And what it does is it essentially looks at pairwise distances between points and tries to find out if a point is farther away from any other point. And then it tries to look for groups of items. That's what the at least this many events filter did to qualify for a cluster. Do you need to have at least 10 points within 10 feet of each other to make a cluster? If it's 5 points, do you call all of them outliers, for example? So this is an iterative method that will loop through the data multiple times to actually find you an answer. So you can't write it as a Tableau calculated field if you want it yourself. And we don't have it as a built-in function. Same thing with gradient boosting. It's a model that we don't have it in Tableau, and you can write that as a calculated field in Tableau.
Cool. I'm not seeing any other questions, but I'm sure for some of the people who have seen this, if you are an admin or a developer for Tableau, developer meaning analyst, how would you get started using Python with Tableau? Do you have any good resources?
So we have 2 blog posts to get started. We have some examples on our GitHub repository as well. Everything I showed, actually we posted the example workbooks that you can find the Tableau blog post, and we can share it after this meeting. You can download both workbooks. If you don't want to download them, you can play with them on public-facing Tableau server. We even have the Jupyter workbook I shared. And that's meant to be a good template because what it does is you can swap out the data set, you can tweak a bunch of things, and you can apply it to a different data set. And It's also a good method if you want to put a neural network instead of a gradient boosting. You can use the same template to extend and do it as well. So it's a good resource by itself, and it's fairly well documented, so you understand every step of what we're doing and get started that way.
Cool. Well, I'm not seeing any other questions, so I think that brings us to the end of our time. So thank you so much, Bora. That was really, really great, and thanks again, Kent. That's awesome. Those are both fun presentations.
Thanks for having us.
Thank you.
Yeah, absolutely. So this presentation will be posted on YouTube. Any relevant files which we are able to share will be posted on the forum as well. And if you have any follow-up questions, Bora and Kent are always in there. So really feel free to reach out. So thanks everybody who joined, and we'll see you next time.